Addition of ordinates. Sometimes we need to sketch a graph of a function that can be seen as the sum of two different functions. So if I have something like, let's say y equals x squared plus x cubed, we can see that that's the same as the function of y equals x squared and y equals x cubed. If I find a y for the same x value there and the same x value there, and I add the two up, it will give me the same as that function, which means I can actually go and draw the function of x squared. So let's say the function of x squared, which looks like that. And I can also draw the graph of y equals x cubed, which looks like that. And then say, let's add all the y values for this one to all the y values of that one. So I say, whatever the value is at this specific point, so whatever that x value is, we add what is the x value or the y value for that x value there, add it to there, and then find my new graph. Now that sounds like a mouthful, but in the examples that we're going to do, I'm going to show you step by step how to do it. What we do then is, in other words, is we break this up into individual values, but instead of doing it algebraically, we're going to do it on a graph. Now, why do we want to do it? Because that is just a cubic function. If I simplify that, y equals x squared plus x cubed, I can actually rewrite that as y equals x cubed plus x squared. I can take out x squared as a common factor. I'm left with x plus 1, and therefore I can draw this graph using my normal equation, because or using translation. The same with y equals x squared plus 1. I can see that as y equals x squared and y equals 1. I can draw the graph of y equals x squared, y equals 1, and then just add the coordinates everywhere and then get a new graph. But I know that this is x squared plus 1, which means all the values will just move one up, which means that's going to give me a graph looking like that. So I'm not going to use the addition of ordinates in this case. I'm not going to use it in this case unless they ask me. But what if they ask me to draw y equals x squared plus square root x? Now I don't know how this graph is going to look like. And therefore what I'm going to do is I'm going to draw the graph of y equals x squared, because I know how that looks like. And then I'm going to draw a graph of y equals square root x, and then add the x values at different points and see what's my new graph going to look like. What you need to understand is I can only draw them if they exist at the same place. So if I look at the domain, remember we add up all the y values, so which means the x values must exist there. If I look at y equals x squared, my graph looks like that, which means that the domain is equal to all real values. For this domain, I find domain is x values. I can find x values anywhere on my real. But if I look at y equals square root x, that graph looks like this. Okay, which means it's only going to exist from the domain for this will only start at 0, including 0, sorry, that's block bracket, including 0 and going to infinity. Which means my rule is that the domain of fx for that whole thing equals the domain of gx, whatever gx is, and the domain of hx, or they call it px. So what it means is, if I want to add these coordinates, I can only add them where both of them exist. So if I draw this on the same graph, it's going to look like this. Let's make this one the pink one, and we make this the green one. If I draw this on the same graph, and I draw the green one over there, this can only exist where both of them, where they both exist, where they add, which means I can only draw them for this distance. If I add these coordinates, I can only add them here because it's the only place where both of them exist. It's in that area that both of them exist, so I can only draw them. So the domain of fx will be only from 0, including 0, to infinity, because that's the only place where both of them exist. So you need to understand, where do this graph exist, where do this graph exist in terms of domain, and only where both of them exist can I draw the graph. When I pick which values, because it's pretty hard to see where I'm going to pick these values to add them, because you should actually add every single x value, but that will take you ages. So when I pick which x values to add, and that will come into the example, there is a few places that I'm gonna write these rules down. So when sketching by hand, this is where I'm gonna look at to add my coordinates. I'm gonna add first of all the end points of the graphs, endpoints of graphs. The second thing that I'm gonna add is the points of intersection of the graphs, so where they intersect. And then third is the x-intercepts of either the graphs. And this I will show you in the example. Okay, so basically this is what it comes down to. We can add graphs by adding the y values on a graph. So instead of doing it the values, I can do it on the graph. I can only do it where both the graphs exist in the domain. And what I'm going to do then is I'm going to add the endpoints of the graphs, the points of intersection, as well as the x-intercepts of either of the graphs. It's very important that you look at worked example 14, 15, and 16 to know exactly how to do this.